Imagine holding a rock that's not just ancient, but a silent witness to the birth of animal life on Earth. This isn't just a stone. It's a messenger from a world 500 million years gone, carrying secrets locked away since the dawn of complex life. In the fossil-rich beds of southern China, scientists recently unearthed such a messenger, Gangtoucunia aspera, a creature whose story was hidden for eons. This tiny animal, no bigger than your finger, is now rewriting our understanding of how life's earliest chapters unfolded. Gangtoucunia isn't just another extinct animal, it's a revelation, offering clues about how the very first skeletons appeared in the animal kingdom. Its discovery challenges what we thought we knew about the earliest architects of animal life, forcing us to rethink the origins of complex bodies. For the first time, we're not just seeing a shell, we're seeing the preserved ghost of the animal itself, a rare glimpse into the soft living parts that almost never survived the ages. Its soft tissues, miraculously fossilized, let us peer into a living organism from the Cambrian seas, revealing details of its anatomy and lifestyle. This is the holy grail for paleontologists, a window into the life, not just the remains, of an ancient pioneer that once thrived in a world so different from our own. As we journey back in time, we'll explore the alien world Gangtoucunia called home, a seafloor teeming with strange and wonderful life forms. We'll also meet the dedicated scientists who painstakingly brought its story to light, piecing together fragments of the past to reveal a bigger picture. This isn't just a scientific report. It's an invitation to marvel at life's ingenuity, to stand in awe of our connection to the first builders of the animal kingdom, and to appreciate the fragile thread that links us to these ancient creatures. Gangtoucunia's story is, in a sense, our own, a tale of innovation, survival, and evolution's endless creativity, echoing through every living thing today. The fossil's discovery forces us to question the very foundations of the animal kingdom, challenging long-held beliefs and opening new avenues of research. It's a detective story, with clues etched in stone and preserved in astonishing detail, waiting for curious minds to decipher their meaning. We're not just adding a name to a list. We're rewriting a fundamental chapter in the book of life, reshaping our understanding of where we come from. The message from Gangtoucunia is clear. The story of life is far more complex and far more fascinating than we ever imagined. And with every new discovery, that story grows richer, inviting us to keep searching, questioning, and marveling at the wonders of our ancient world. To truly understand Gangtoucunia, we must journey back in time to the Cambrian Period, over 500 million years ago, a time when our planet was almost unrecognizable compared to today. The continents were scattered and unfamiliar, the land above water barren and lifeless, while all forms of life thrived beneath the ancient waves in a world ruled by the oceans. The oceans teemed with bizarre and alien-looking creatures. Trilobites scuttled along the seafloor, Anomalocaris hunted with its strange appendages, and Hallucigenia crawled on spiny legs, each more peculiar than the last. This was a world of wild experimentation, where nature tested countless body plans and evolutionary ideas, many of which would never be seen again. Oxygen in the atmosphere was scarce, the sun shone dimmer than it does now, and yet, against all odds, life exploded in diversity and complexity. The Cambrian explosion marked a turning point, as the ancestors of nearly all modern animal groups appeared in a geological blink, forever changing the course of evolution. Into this bustling, dangerous, and ever-changing world emerged Gangtoucunia aspera, a creature unlike any other. It lived anchored to the seafloor, a tiny stationary animal surrounded by swift predators and strange neighbors, relying on its unique adaptations to survive. To protect itself, Gangtoucunia built a hard, tube-like skeleton, a remarkable home and a vital shield against the dangers of Cambrian seas. For many years, scientists thought they knew which animals were the first to build skeletons, believing the story was simple and straightforward. But the discovery of Gangtoucunia's fossil reveals a far more complex and surprising story than anyone expected. It shows that the ability to build skeletons appeared much earlier and in more unexpected groups than we ever believed possible. The Cambrian seas were a crucible of innovation, and Gangtoucunia was one of its true pioneers, helping to shape the future of animal life. Its fossil forces us to rethink the origins of animal architecture, challenging our assumptions about how and when complex life began to build. The story of early life is richer, more intricate, and more astonishing than we ever imagined. with each new discovery opening a window into our planet's mysterious past. Our story begins in the fossil-rich rolling hills of southern China, a region famous for its ancient secrets hidden beneath layers of stone. Here, dedicated paleontologists have spent years searching for traces of life from Earth's distant past, carefully combing the ground for clues. Among their most intriguing finds were small, tube-like fossils, remains of a mysterious creature known as Gangtoucunia aspera. For decades, these ancient tubes puzzled scientists. Many believed they were simply the abandoned homes of prehistoric worms, nothing more. But then, the Danshui Biota changed everything. This extraordinary fossil site offered something incredibly rare. Conditions perfect for preserving not just hard skeletons, but also delicate soft tissues that usually vanish with time. Rapid burial in fine, silty mud and a lack of oxygen sealed these ancient creatures in a stony time capsule, protecting them for over 500 million years. Thanks to this, scientists could finally glimpse for the very first time the ghostly outline of the animal that once lived inside the tube. The discovery was nothing short of a revelation. The mysterious tube dweller was about to reveal its long-hidden secrets to the world. Careful, painstaking examination revealed astonishing details. Preserved soft parts like muscles, digestive tracts, and even ancient mouth parts. The patient, meticulous work of the research team finally paid off, unlocking a 500 million-year-old mystery that had baffled experts for generations. What they found inside was not a worm at all, but something far more surprising and significant. This remarkable find would force scientists to rethink and reevaluate the evolutionary tree of life as we know it. The empty tubes that had puzzled generations of scientists now finally had a face, and a fascinating story to tell. The Danshui Biota's unique preservation conditions truly changed everything, opening a new window into ancient life. The true identity of Gangtoucunia was about to be rewritten, forever altering our understanding of life's early history. The true marvel of Gangtoucunia lies in its preserved soft tissues. For the first time, scientists could see the animal's internal structure: thin partitions, a crown of tentacles, and a simple gut. This was not a worm, but a polyp, a tiny anemone-like creature anchored inside its tube. Its tentacles waved in the water, catching food just like modern sea anemones. The fossil revealed Gangtoucunia as a member of the cnidarian family, relatives of jellyfish and corals. This was a shocking revelation, overturning decades of speculation. Gangtoucunia was a jellyfish ancestor living in a shell, not a complex worm. It showed that early cnidarians could build hard skeletons, a level of sophistication previously unimagined. The discovery bridges the gap between soft-bodied animals and those with protective skeletons. Gangtoucunia's life was more complex and more influential than anyone had guessed. Gangtoucunia's skeleton-building ability has upended our timeline for biomineralization. Previously, scientists thought only more complex animals evolved skeletons this early. But Gangtoucunia proves that even ancient cnidarians mastered this innovation over 500 million years ago. This suggests the genetic toolkit for building skeletons was present in more animal groups than we realized. Biomineralization may have been a widespread potential, activated in different lineages in unique ways. Gangtoucunia is the first clear evidence of this in the cnidarian line. This fossil unlocks a new perspective on the Cambrian explosion and the dynamic, innovative world of early animals. The Cambrian explosion was life's greatest burst of innovation. In just a few million years, nearly all major animal body plans appeared. Predators and prey drove an evolutionary arms race, spurring new defenses and strategies. Gangtoucunia is a perfect example, a soft-bodied polyp that built a hard tube for protection. Its skeleton was a direct response to the dangers of its world. This advanced defense in such an early animal group adds new complexity to our understanding of evolution. The Cambrian seas were a crucible of creativity, and Gangtoucunia was one of its engineers. Its story shows how ecological pressures shape the future of life. Discoveries like Gangtoucunia's are the result of teamwork, expertise, and perseverance. Dr. Guangshu Zhang led the fieldwork in China, identifying the best sites for fossil hunting. Dr. Luke Perry from Oxford recognized the fossil's true nature, a cnidarian, not a worm. Their collaboration, along with advanced imaging and painstaking fossil preparation, revealed the animal's secrets. Each new detail confirmed Gangtoucunia's place in the cnidarian family tree. This story highlights the human side of science: curiosity, patience, and the thrill of discovery. The team's work opened a new window into the deep past. Their efforts remind us that science is built step by passionate individuals. Gangtoucunia's story is a testament to international collaboration and the enduring excitement of uncovering our planet's history. Through their work, a vanished world comes alive once more. The Danshui Biota, where Gangtoucunia was found, is a rare window into ancient life. This Lagerstätte preserves not just hard shells, but also the soft parts of animals, offering a complete snapshot of a Cambrian ecosystem. Most fossils only capture creatures with hard parts, but Danshui reveals the true diversity of early seas. Calm waters and sudden mud flows buried animals quickly, preserving even delicate tissues. Without these unique conditions, Gangtoucunia's soft body would have vanished, leaving only its tube. The Danshui Biota continues to yield fossils that fill crucial gaps in our knowledge. Each discovery adds a new character to the story of early life. This site is a treasure trove, revealing a world richer and more surprising than we ever knew. Gangtoucunia aspera reminds us that the story of life is always evolving. This tiny fossil reshaped our understanding of animal origins and skeletal innovation. It shows that evolution is not a straight line, but a creative, branching labyrinth. The cnidarians were early pioneers in skeletal engineering, even if many descendants later abandoned it. Each new fossil discovery is a piece of our own origin story. By studying these ancient pioneers, we learn about life's resilience and creativity. Gangtoucunia's message, carried across 500 million years, inspires wonder and anticipation for the next chapter in the story of life.